Okay, so hello. Today we are going to be talking about inverse functions. So we're still not quite into like the actual meat of chapter 10, which is log and exponential functions, but we are learning about important parts that will get us there. So today we're talking about inverse functions. So part 1 is determining whether a function is one-to-one. So the main idea of chapter 10 is exponential and logarithmic functions. These two types of functions have a special relationship to each other. They are inverses. Therefore, before we go into exponential and logarithmic functions, we're going to need to talk about inverse functions. First, however, we need to talk about one-to-one functions. So to get to exponent and logs, we need to talk about inverses, and to get to inverses, we need to talk about one-to-one. Thankfully, inverse one-to-one, not too bad. Okay, definition. For a one-to-one function, each x value corresponds to only one y value, and each y value corresponds to only one x value. So in the following example, we are asked whether each function described is one-to-one. So if we're looking at f, we see we have 6, 2, 5, 4, negative 1, 0, and 7, 3. And so that would be a one-to-one function because each that y value corresponds to only one x value. Let's look at G now. G, we have 3, 9, 4, negative 4, 2, negative 3. Oh, negative 3, 9. That is a y value that has already been used. So therefore, I do not have a unique x value for every y value because I have the y value of 9 that corresponds to two different x values. And so G would not be one-to-one. That's basically one-to-one functions. So that's not too bad. The horizontal line test as well is not too bad. So remember that we can use the vertical line test to determine if we're looking at the graph of a function. And to test whether the graph of a function is one-to-one, we use the horizontal line test. So if every horizontal line intersects the graph of a function at most once, then the function is one-to-one. Then the function is a one-to-one function. Quickly write out what we were defining there. That is the formal definition of our horizontal line test. And I will leave the math lab problems to ask that because it's really pretty straightforward, just drawing a line. So that brings us to part 3, finding the inverse of a function. So one-to-one functions are special because they pass both the horizontal and vertical line tests. They are also special because we can find the inverse of one-to-one functions simply by switching the coordinates of the ordered pairs of a function. So for instance, if f equals 2, negative 3, 5, 10, and 9, 1, which is one-to-one, then the inverse of x, which we denote as f to the negative 1, so whenever you see that, that is f inverse, or the inverse of f is how we say it, is negative 3, 2, 10, 5, and 1, 9. So literally just took those xy points and switched them. That's it for finding the inverse of a function. And then part 4 is finding the inverse of a function if we're actually given like a function instead of a bunch of ordered pairs that we can just like switcherooski. And so this is also pretty straightforward, not too bad. So the way that we do this is we replace f of x with y. So remember, those are both ways that we can denote functions. We could write it as f of x equals x squared plus 2 or y equals x squared plus 2. Doesn't matter. So we replace f of x with y, we interchange x and y, solve the equation for y, and then replace y with the notation f inverse of x. So for instance, find the equation of the inverse of the following functions. So f of x equals x plus 3. Step 1, replace f of x with y. Y equals x plus 3. Step 2, interchange x and y. X equals y plus 3. Step 3, solve the equation for y. X minus 3 equals y. Step 4, replace y with the notation f inverse of x. F inverse of x is equal to x minus 3. And that's literally it. Nothing too bad at all. Number 2, let's do another little example here. We know f of x is equal to, I don't know why that's not erasing. Maybe if I stop screen sharing and then rescreen here. That seemed to do the trick. All right. Number 2, f of x is equal to 3x minus 5. F of x equals 3x minus 5. Step 1. Step 2. Step 3, x plus 5 equals 3y. And then step 4, f to the negative 1 of x equals x plus 5 over 3. And that would be the inverse of 3x minus 5. So as a whole, nothing too bad. Hopefully the math lab helps you practice if you don't quite get it yet. And if not, bring any questions you have to class and enjoy your day. Thanks for watching. Hopefully you did watch it. I sometimes feel like I'm just speaking to myself in these, but here we are.